Oh, hi guys. Sorry, I've just got to go back to the start. So I hope you had a really good holiday, especially those of you that are overseas. I hope everything's kind of tracking all right, and you're safe and your families are well, and all of those kind of happy things. Um, Obviously, it's been pretty boring here, but that's all right. I'm still in the country, so that's nice. And you know what? We hopefully, we might be back at school at some stage. Who knows? But definitely not. I think for a few weeks. So the plan is that we're going to finish off statistics. We're then going to move on to pure year 2, which should be lovely. And from there, we'll just keep going because your exams won't be till the start of next year. Okay, so what we're looking at now is hypothesis testing. Now, this is tricky. It takes a long time to get your head around. Trust me, there's lots of weird terminology, and there's kind of a bit of convoluted thinking. So don't stress too much if you're really panicking at the moment. What I would like is to have maybe a quick Teams meeting on Wednesday, and then for anyone who is really struggling, maybe we can meet up individually Wednesday afternoon, or you can have a bit more time to consolidate, etc., etc. Okay, I would rather chat to you one-on-one, or give you more time to ask questions, so I can make you kind of individual videos or anything you need, rather than having a really long Teams session. So Wednesday, I'll make another video for you, a quick Teams meeting, but that should be fine. Alrighty, what we're going to focus on this year is binomial distribution hypothesis testing. But next year, when you come into your major A-level course, you'll look at other types of hypothesis testing as well, with normal distributions and other distributions. Okay, first thing we need to talk about is what is a hypothesis. Now, most of you should know this from science. For many, many years, a hypothesis is something that you're predicting or you're thinking about being true. When we're looking at hypothesis testing in maths, we talk about there being 2 hypotheses. What we call a null hypothesis. Okay, the null hypothesis is the hypothesis you assume to be correct. Okay, and we call that H0. Okay, that's our notation for null hypothesis. The alternate hypothesis tells you information about your parameter if the null hypothesis is rejected. Okay, and we call that H1. So what happens is you make a hypothesis, that's your null hypothesis, what you're assuming to be correct. If you find that that is not correct, then you have this backup hypothesis, this alternate hypothesis, and that tells you information if your null hypothesis is rejected. Okay, when we're looking at testing a hypothesis, we have what we call a test statistic. Now, that's literally what you're doing in order to determine whether your hypothesis is right or wrong. And we have a probability of observing that result, which is what we call a p-value. Okay, we've already looked at probabilities with p-values before, so much like what we were doing in binomial distribution. Okay, so we're going to look at this first example. John wants to see whether a coin is unbiased or whether it is biased towards coming down heads. Now, we know for an unbiased coin, okay, we would expect our probability to be equal to 0.5. Now, when you're forming your null hypothesis, you're always looking at where a probability is equal to a certain value. Okay, he tosses the coin 8 times, big sample size, and he counts the number of times x that it lands head uppermost. So the first thing is what the test statistic. So like I said, the test statistic is what you're doing in order to get your results. So the test statistic, in this case, is x, the number of times he obtains heads, okay, out of a certain number of coin tosses. Okay, B, write down a suitable null hypothesis. So in this case, our null hypothesis, H0, is where our probability is equal to 0.5. Okay, because we're finding where is it equal to. We know that if it's 0.5, that means that it is unbiased. Now, if the second part is a little bit more confusing, we're wanting to find a suitable alternate hypothesis. So with our alternate hypothesis, H1, because we're trying to find whether this coin is biased towards heads. If it's biased towards heads, we would then expect our probability to be bigger than 0.5. Okay. If we were testing whether it was biased towards tails, but we were still looking at the number of times heads lands, then that probability would be less than 0.5. But because we're looking at whether it's biased towards heads, we're expecting a bigger probability for heads, so probability greater than 0.5. Right, hope that makes sense. So what happens from here is we would then run the test, we would obtain a certain probability, and from that we would obtain a certain a certain probability. Now that probability would tell us whether we accept or reject our null hypothesis. Okay, I like to think about it in terms of I just lost my spot. I like to think about it in terms of a flowchart. So we have our population. Okay, we determine what our test statistic is going to be, and we also determine our hypotheses. From that, we take a sample, we test that sample, and we obtain a result. And from that result, if we have a certain, what we call level of significance, if our test result is above that level of significance, we would accept our hypothesis, because that above that level of significance, that would tell us that there's a small chance that we have incorrectly, hang on. Okay, so if that test result is above that certain level of significance, we can then accept our hypothesis and say that that's true. If that test result is below that significance level, then we reject the hypothesis and then we accept our alternate hypothesis instead as being true. Okay, the significance level refers to the certainty with which we have rejected that null hypothesis. Okay, so it tells us how certain are we that if we rejected it, we rejected it correctly. Okay, so for example, you've got a 1% significance level. That means there's a 1% chance that we have incorrectly rejected our null hypothesis. Okay, so if your significance level that you find is below 1%, that means that there's a higher chance that you have incorrectly rejected your null hypothesis. And this is where it's a little bit tricky. If it's above that level, that means that there's a higher chance that you haven't incorrectly rejected it, and so we accept it. Okay, the most common significance levels that you can use to test are 1%, 5%, and 10%. Okay, but you can test for any level of significance, and the question will tell you what level of significance you're testing for. Okay, the second example here, I've written it down already, just to save a bit of time. So you can go through and copy that down, or however you want to do it. So we've got an election candidate believes that she has the support of 40% of her residents in a particular town. The researcher wants to test at the 5% significance level whether the candidate is overestimating her support. The researcher asks 20 people to say whether they support the candidate or not, and 3 people say that they do support her. So we want to write down a suitable test statistic. So our suitable test statistic, what we're testing for, is the number of people who support that candidate. Our 2 hypotheses, firstly the null hypothesis, she thinks that there's 40% of people who support her. So we're testing to see whether whether she's right, so whether that probability is in fact equal to 0.4. We therefore are looking at, if we're looking at an overestimation, we're looking at that probability being less than 0.4. So our alternate hypothesis is that that probability would be less than 0.4 and she would be overestimating. The tricky bit here is explaining the condition under which the null hypothesis would be rejected. So the null hypothesis is rejected if those 3 or fewer people that they found saying that they supported the candidate is less than the significance level, so less than 0.05, given that your probability is equal to 0.4. Okay, so under that case, we would reject the null hypothesis because our probability is less, our significance level is less than 0.05, and then we would say that she probably is overestimating. Now, this is all pretty tricky. It's wordy. What I think you should do, I think it gets easier once you actually start doing the testing, and once we can kind of see how it works. So I would suggest watching the video for 7.3 and then maybe coming back and doing 7A and 7C together, and I think that will help you quite a bit. Okay, but I'm going to upload this now and I'm going to make the next video. Okay.